Jonathan Brendefur, and today I'm going to talk to you about fractions. So fractions, we typically talk about the numerator and the denominator. A lot of times we talk about the numerator is a number and the denominator is a number. But just to be clear, a fraction is a number, and it's composed of the top digit and the bottom digit. But we're going to talk about it in a slightly different way today. And first of all, I want you to be able to do a task with me. So if you could draw a rectangle and partition it. And partition means to split into equal sections. So partition into 4 equal sections. And then I want you to tell me what you think is the fractional amount that goes here and here. Now, typically I'll pause when I'm working with kids, 3rd grade, 4th grade, and 5th grade, and ask them, what do you think? And they'll all start working. And as they start working, I'll ask, do you have any questions for me? What question do you want to ask before you fill that out? No questions. Okay. As they're working on that, and as you might be working on that, I put 0 here, and I place 1 here. As they look up, about half the students will go, wait a minute, you put the 1 in the wrong place. Or they're like, oh, I know what I should be working on now. So as you do this, this here would be a 1/3 unit, 2/3, 3/3, and 4/3. Back here we'll add 0/3. So what goes here, the question mark is 1/3 unit, and this is 4/3 at this place. Now this takes us back to what the numerator and denominator is. So the numerator, if we look at where words come from, so the etymology of words, where does numerator come from? It actually comes from the word enumeration. To enumerate means to count. So this top digit is also our counting digit. So the numerator is easily thought about as the count. Right here we have 0, 1, 2, 3, 4. We have a count, but what are we counting in? That gets us to our denomination, our denominator, which focuses on denominations. How do we name something? Or in Spanish, nombre, to name. So the denominator talks about how do we name something. Well, here, to talk about how we name a fraction is, so we can talk about the unit size. In this, we have the size of 1/3, but how do we get there is how many equivalent units to compose or to build to 1. So a lot of times, so that's the question we have to ask. How many smaller equivalent units, so these are all equivalent units, how many are there to compose 1 is 3 of them, so then this is named thirds. Now, the reason I did this type of task is so that we don't confuse the word whole with 1. So yes, this is the whole 1, it's a whole number, that's where that comes from, but it's important to actually have kids focus on the unit of 1. So how many of these smaller equivalent units get to 1? Okay, so let's try another task here. So draw another rectangle, partition into 4 equal sections. And again, I'm going to ask you, what do you think are the fraction amounts there? They're not 1/4, unless I put 0 here and 1 at the end. I am not. What if I put 1 here? Now, how do we name these units? We go back to the denominator as the unit size. How many equivalent units to get to 1? There are 2 of them, so these are called halves. 0 halves, a count of 1/2, count of 2 halves, 3 halves, and 4 halves. 2 halves are equivalent to 1, so another 2 would be equivalent to another whole number of 2. So then we can have the improper fractions related to the whole numbers. Again, we're counting 4, just like we counted 4 here, but what are we counting in? We're counting in units of thirds, we're counting in units of halves. Then we can start asking the questions like, what do you notice about this digit? When the digit is larger, it takes more of these units to get to 1. When this digit is larger, then it takes less units. Okay, let's try one more. take another rectangle, partition it into 4 equal sections. Going to ask you what those fractional amounts are. So again, now we're starting to ask where is 0 and where is 1. If we place 0 here, and this time, right in the middle of that unit, I'm going to put 1 right there. So now again, we go back to ask our questions. Okay, what goes here then? For the denominator, we have to have equivalent units. We don't have, this unit is larger, twice as large as this unit. So that forces us to have to do a partition. So we have to have all equal sections. So we partition all of those in half. Now we can count and go 1, 2, 3 to get to 1. So each of these little sections here, that would be a 1/3, 0/3, 2/3. Here, this was 3/3, 4/3, 5/3, 6/3, 7/3, and 8/3. So here is that first question mark would have been 2/3, and the end would be 8/3. Where would be equivalent whole numbers? Well, it takes 3 to just get to 1. So another 1, 2, 3/3. 6/3 would be 2. 1, 2, 3. If we did 1 more, that's where 3 would be, which would also be 9/3. So that wraps up a little explanation about what fractions are. So thinking about fractions, fraction comes from that word fracturing, breaking something, but it's breaking it into smaller equivalent units. If we think about the numerator as the count, always the count, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 here, but the denominator, what are we counting in? What size unit? How many smaller units to get to 1? Now, that language, that structure of mathematics really helps kids early understand what fractions are, which helps alleviate a lot of issues when you hit algebra, like terms, just like here with like denominators or equal size units. That's going to help us as we now move into addition, subtraction, and then multiplication, division of fractions. So stay tuned. We're going to do a quick example of each of those 4. Thank you.